Hello friends, this is Priyanka. Today we are going to solve a problem on write the differential equations for a given electrical network. We are also going to find out the ratio of EO of S to the EI of S. This is the ratio of output to input. So let us first understand what is the given electrical circuit. Now if we observe this circuit, this is the combination of two loops and these two loops are parallel to each other. So we can say that the current flowing in each loop is different. So I will show this current. So in first loop the current I1 is flowing and in the second loop current I2 is flowing. Now in first loop input EI is there, then the element R1 and inductor L is there. Now the resistor R2 and capacitor C is the part of loop 1 as well as loop 2. Then at this loop 2 there is the R3. That is the resistor R3 is the part of loop 3. And the output EO is along this resistor R3 is given. Now how to write the differential equation? So for this differential equation we know that we have to write input is equal to, we will write these all the elements in terms of voltage V. So these all elements, if we observe for this resistor R1 and inductor L, the current I1 is flowing. Now for this R2 and C, it is related to current I1 and I2, and this R3 is related to current I2 only. Now while writing the differential equation, we have to write the differential equation for loop first and then loop second. So first I will take the loop 1. So for loop 1 there is the input. So input is equal to, we have to take all the elements in terms of voltage. So I will write input EI is equal to, I will write R1 in terms of voltage. So how to write? So voltage V is equal to is nothing but Ri. So these three formulas are important. Voltage V in terms of resistor is V is equal to Ri. Then in terms of inductor is V is equal to L di by dt. And in terms of capacitor is V is equal to 1 by C integration of I dt. So please note down these three important formulas. Now I will take first element R1. Now R1 is, for this resistor R1 current I1 is flowing. So how to write? R1 I1. Then I will write inductor L. So L current I1 is flowing. So how to write? That is plus L di1 by dt plus. Now I will take next element resistor R2. Now it is the part of the current I1 I2. So I have to take the difference. But this is the equation for loop 1. So while taking difference I will take I1 first. So how to write? That is plus R2 in the bracket I1 minus I2. Then capacitor C. So for this capacitor C also I have to take the difference. So I will write plus 1 by C integration of, I have to take the difference, that is I1 minus I2 bracket complete dt. So this is the differential equation. Now we know that we have to also find out the ratio of EO of S to the EI of S. That is, S means here we have to take the Laplace transform. So I will write what about this equation by Laplace transformation. So here it will become this current I, and here is also current I, that is here I1 I2. In this equation these are variables. So for these variables we have to write this equation in terms of S. So EI, that is left hand side, will become EI of S is equal to R1 I1. So here it will become R1 I1 of S, then plus L dI1 by dt. So here this is the differentiation. So we have to cancel this differentiation. So here for this differential equation there is only order 1. So for this first order we have to take here L into S, because we have to cancel this d by dt, and remaining is I1. So I will write here I1 of S plus, now here R2 I1 minus I2. So here I will simultaneously take this R2 or multiply this R2 inside the bracket. So here it will become R2 I1S, R2 I1 of S minus R2 I2 of S plus, now 1 by C integration of. So we have to cancel this integration. So for Laplace transformation, to cancel integration we have to multiply with 1 by S. So it will become 1 upon Cs. Now I will multiply this 1 by Cs simultaneously inside the bracket. So it will become 1 by Cs I1 of S minus 1 by Cs I2 of S. Now we will simplify this. So how to simplify? That means we have to take I1 on I1, that is as a common, and I2 as a common. So first I will take I1 as a common. So here R1 plus L dot S plus R2 plus 1 by Cs. So these are the coefficients of I1. So I will take here I1 of S as a common. Now what about I2? So I2 is having minus sign. So this minus sign I will take outside the bracket, and inside the bracket it will become R2 plus 1 by Cs. Bracket complete, I2 of S. Now if we observe, if I multiply this inside, it will become minus R2 I2 of S and minus 1 by Cs I2 by S. So here this is the equation. So this is the simplified equation. So we can say that. Now we will move for the loop second. So I will write here loop 2. So for loop 2, how many elements are there? R2, C and R3. These are related to loop 2. Now R2 and C are combined element, that is combined both. R2 and C are the part of loop 1 and loop 2, and R3 is only part of loop 2. Now if we observe, we will take these elements only, and no input and no output is there. Now for output I will take again next equation. So for these elements I will take in terms of voltage. So how to take? Now this R2. So R2 is the part of this loop 1 and loop 2. So I have to take the difference of this current. So we are going to write the equation for loop 2. So I have to take I2 first. So how I can write here? R2 I2 minus I1. That is, this is the equation. Now again I will take capacitor. So capacitor C is there. So how to write? I have to again take the difference for this current I. So 1 by C integration of I2 minus I1 bracket complete dt plus R3 is related to I2 only, plus R3 I2. So summation of all these voltages is equal to 0. Now I will take the Laplace transformation. So how to take the Laplace transformation? So instead of this I have to write I of S. Now by Laplace transformation. So this is the differential equation. Now I will take the Laplace. So I will multiply simultaneously multiply these elements inside the bracket. So here simply I will write R2 I2 of S minus R2 I1 of S plus. Now we have to cancel this integration. So I will take 1 by Cs. To cancel this integration, I have to multiply with 1 by S. So 1 by Cs I2 of S minus, I will multiply this 1 by C inside the bracket, that is minus 1 by Cs I1 of S plus R3 I2 of S is equal to 0. Now I have to again simplify this. So I will take I1 as a common, I2 as a common. So I1 term, there is only two I1 terms, so I will take, now minus sign I will take outside the bracket, R2 plus 1 by Cs bracket complete I1 of S plus R2 plus 1 by Cs plus R3 bracket complete I2 of S is equal to 0. So this is the simplified form. Now again we will move for the output. So output EO is along this resistor R3 only. So how I can write this? EO is equal to I2 R3. So I will write here EO. So I will write here because this is a very small equation. So EO is equal to R3 I2. So how we can take here Laplace transformation? So I will take Laplace transformation for EO of S is equal to R3 I2 of S. So this is the equation. So I will give here now question is that we have to write the differential equation. So this is the differential equation, equation number 1. This is second differential equation and this is third differential equation. So this is the answer of first question, that write the differential equation about this circuit. And now we will move for the second question, that we have to take ratio of EO of S by EI of S. So how to take this ratio? So for that we have to simplify this. Now we can write this EI of S in terms of EO of S. So how to write? So here EO of S is nothing but R3 I2 of S. So we will remove I1 from this equation. So how to remove? So for that, from this second loop equation we will take the value of I1 in terms of I2. So how to take? So if we observe this equation, it is simple. Now I will use different color marker. So what is the value of I1 of S? Therefore I1 of S is equal to, I will take this term to the other side, R2 plus 1 by Cs plus R3 into I2 divided by, now this term if I move to the right hand side it will become minus, but here is also minus sign, so minus sign is getting cancelled. Here I2 of S and here divided by R2 plus 1 by Cs. So this is the value of I1 of S. So how to take this? That is, we have to replace this whole term, transfer this whole term to the right hand side, and then we have to transfer this coefficient of I1 of S to the denominator. Now this value of I1 of S we have to put here. Then we will get the I2 of S, that is this equation in terms of I2 of S. So again I will write this equation, EI of S is equal to R1 plus LS plus R2 plus 1 by Cs. Now instead of I1 of S I have to write this, R2 plus 1 by Cs plus R3 divided by R2 plus 1 by Cs, I2 of S, minus R2 plus 1 by Cs, I will use here square bracket, and I2 of S. Now this I2 of S we can take as a common term. So if I take this I2 of S as a common, then again I will get EI of S is equal to I2 of S as a common term. Then again inside the bracket I will take R1 plus Ls plus R2 plus 1 by Cs, R2 plus 1 by Cs plus R3 divided by R2 plus 1 by Cs, and minus, here it will become R2 plus 1 by Cs. If we observe this equation, it is in terms of EI of S and I2 of S. Now, if I multiply on both sides with R3, then here R3 I2 of S we can replace with EO of S. Now, if we observe this equation, we will also simplify the terms inside the bracket. We will take this denominator R2 plus 1 by Cs as a common denominator for this whole term. So how to take? So first I will multiply here on both sides with R3. So R3 EI of S is equal to R3 I2 of S. Now inside the bracket, for this whole term, this denominator is R2 1 plus Cs. So if I multiply this term R2 1 plus Cs to this, then after that we can take the whole denominator as a R2 1 plus Cs. So how this equation? That is R1 plus Ls plus R2 plus 1 by Cs. In second bracket R2 plus 1 by Cs plus R3 minus. Now these two terms are same. So I can take here R2 plus 1 by Cs square and bracket complete. And to the whole denominator we will take here as a common denominator. Now this R3 I2 of S is nothing but EO of S. So I will transfer this EI of S to right hand side, and I will transfer the whole term inside the bracket to the left hand side. So this R2 plus 1 by Cs will move in the numerator. So R3 as it is, R3 in the bracket R2 plus 1 by Cs divided by, I have to take this whole numerator to the denominator, and which is equal to EO of S to the EI of S, and this is the required ratio.